Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble code P0339, specifically related to the Crankshaft Position (CKP) sensor circuit intermittent interruption for the Honda CR-V 2023 and newer models. When the engine control module, also known as the powertrain control module (PCM), detects an irregularity in the CKP sensor signals, it registers this DTC. The CKP sensor is a critical component that provides the PCM with the necessary information regarding the position of the crankshaft. This information is vital for the engine's fuel injection timing and ignition timing, ensuring optimal engine performance. If the PCM recognizes a discontinuity in the pulse signals beyond a set threshold, it will flag DTC P0339. Understanding this error code is vital for diagnosing and rectifying issues related to engine performance. The DTC P0339 points to a problem specifically with the crankshaft position CKP sensor circuit, which is critical for the vehicle's engine management system. The CKP sensor is typically located near the crankshaft and communicates the position of the crankshaft to the PCM. The PCM uses this data to adjust ignition and fuel timing, making it essential for efficient engine operation. The CKP pulse plate, which the sensor reads from, is also crucial. If this plate is damaged or loose, it could cause intermittent signal failure. If a fault occurs in the connection from the CKP sensor to the PCM or in the pulse plate itself, the PCM may conclude that the CKP signal is unreliable, triggering the DTC code. Locations of these components are specified in the vehicle's Diagnostic Components Location Index, ensuring technicians can find them without complications. The DTC P0339 can originate from several issues. A faulty CKP sensor itself is a primary suspect. If the sensor has been damaged or has become worn over time, it may not produce reliable signals, misleading the PCM. Another key cause could be poor connections within the circuit. Both the CKP sensor circuit connectors and terminals should be assessed for any signs of looseness, corrosion, or disconnection. Finally, the CKP pulse plate may also be problematic. If it is damaged or not positioned correctly, it may not allow the CKP sensor to read the crankshaft position reliably. These issues highlight the importance of thorough inspection and maintenance of electrical components and connections to ensure the engine management system functions correctly. Drivers experiencing DTC P0339 may notice a variety of symptoms affecting their vehicle's performance. A common symptom is engine stalling, which can occur suddenly as the PCM loses reliable input from the CKP sensor. Consequently, you may experience poor engine performance overall, such as rough idling, reduced acceleration, or irregular engine behavior. Additionally, the check engine light will likely illuminate on the dashboard, signaling that the vehicle's computer has detected an issue that needs attention. Understanding these symptoms is crucial for timely diagnostics and repairs, as neglecting them can lead to further engine complications and may even result in reduced vehicle safety. In troubleshooting for DTC P0339, the first step involves starting the engine and allowing it to idle for at least 10 seconds. This initial observation is crucial as it establishes a baseline for engine performance. After idling, the technician should utilize the HDS or Honda Diagnostic System to monitor the engine control module's outputs specifically for the DTC P0339. If the DTC reappears within this testing period, it indicates that there is still an underlying issue with the CKP sensor circuit or associated components. Properly conducting this step ensures that the technician gathers the necessary diagnostic information to proceed effectively with further inspections. The second step in troubleshooting DTC P0339 requires a test drive of the vehicle to replicate normal operating conditions. During this process, it is vital to monitor both engine speed and vehicle speed to ensure that the vehicle is functioning within designated parameters. Keeping these parameters within the range shown in the onboard snapshot data from the HDS is essential. This part of the diagnosis checks whether the CKP signal behaves as expected during real-time driving situations. Once again, after the test drive, you should check the HDS for DTC P0339. This approach helps confirm whether the underlying issue has been resolved or if further inspection is necessary. In the third troubleshooting step, attention is directed toward the CKP sensor circuit connectors and terminals. It is imperative to check for secure connections, as loose terminals can cause intermittent signals, leading to the P0339 error. Technicians should inspect the connectors at both the CKP sensor and the PCM for any signs of damage or corrosion. If abnormal conditions are discovered during this inspection, this indicates that there may be a deeper issue within the electrical connections that needs to be addressed. Ensuring the integrity of these connections plays a critical role in the operability of the CKP sensor and subsequently the overall engine performance. The fourth troubleshooting step focuses on inspecting the CKP sensor circuit terminals, emphasizing both the engine ground and body ground. A proper ground connection is vital for the effective operation of electrical components, including the CKP sensor. Inspect these grounds closely for any signs of corrosion or weakness in the connection points. If the terminal conditions are abnormal, it is indicative of potential disruptions in the electrical flow, which could lead to erroneous signals from the CKP sensor. Checking these grounds is essential for confirming that all electrical components function efficiently and consistently without intermittent failures. In Step 5, a visual inspection of the CKP pulse plate comes into play. This component must be examined for any signs of looseness or physical damage, as such issues can impede the operation of the CKP sensor. Before conducting the inspection, the CKP sensor itself should be removed for better visibility. Any abnormalities found, such as cracks or excessive play, warrant replacement or further investigation. Normal conditions dictate that the CKP pulse plate should fit snugly and exhibit no signs of wear or damage. Identification of any issues at this stage can direct the technician to the root cause of the DTC P0339. The final troubleshooting step involves a thorough inspection of the CKP sensor itself. If previous inspections indicate that all other components are functioning correctly, it likely points to the CKP sensor being the faulty element. This sensor must be tested for its operational functionality, and if it is found non-operational or gives unreliable readings, it should be replaced immediately. Accurate readings from the CKP sensor are essential for maintaining optimal engine performance. Replacing a faulty CKP sensor can prevent further complications and restore proper engine operation, ensuring reliable vehicle performance. After completing all relevant inspections and repairs for DTC P0339, it's crucial to subsequently verify that the work performed was successful. This process begins by erasing the DTC from the PCM to reset the system, clearing any previous error codes recorded. Following this, a test drive is necessary to evaluate the overall functionality of the vehicle under typical driving conditions. During the drive, carefully monitor the system for any recurrence of the P0339 code. If the code does not return, it indicates that the issue has been effectively resolved and the vehicle is operating as intended without any faults related to the CKP sensor circuit. To mitigate potential issues that could lead to DTC P0339 in the future, preventive maintenance practices should be implemented consistently. Regular inspections of all electrical connections in the CKP sensor circuit will help detect wear, corrosion, or looseness before they escalate into larger problems. Additionally, routine checks of the CKP sensor should be part of standard maintenance procedures. Ensuring that this critical component remains functional will help prevent unexpected engine performance issues. Should any problems arise, addressing them promptly can help maintain vehicle reliability and longevity. Implementing these maintenance strategies can result in significant savings on repairs and enhanced performance. In conclusion, the DTC P0339 relates to an intermittent interruption within the crankshaft position sensor circuit, primarily impacting the functionality of the CKP sensor and the PCM. By identifying symptoms such as engine stalling and poor performance, drivers can seek timely professional diagnosis. A systematic approach to troubleshooting involving careful inspections of connections, terminals, and the CKP pulse plate will lead to effective resolution. After repairs, final verification ensures that the issue has been successfully addressed, preventing future complications. Regular maintenance can play a vital role in averting similar DTC codes, ensuring longevity and optimal performance of the Honda CR-V 2023 Plus models. Please like and subscribe to the channel. See you next time.